Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you appreciate what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can help me promote my channel, keep me going, refreshed and inspired. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Analyze the frame shown below by slope deflection equations, constructing the shear force and bending moment diagrams. By constructing the shear force and bending moment diagrams, then also sketch the elastic curve. E is constant for this situation because we have members with different moment of inertia. So take note that A and D are pin supports, and this frame will not undergo sidesway because there is a restraint at the upper level. So this frame, especially the upper part, cannot move laterally from the theoretical point of view, and this is an unsway frame. So setting up moment BA, moment A is 0, so the formula is 3EI over L, quantity theta near theta B minus delta over L. There's no delta because there's no side sway. Then minus fixed moment near, fixed moment at B, minus 1/2 fixed moment at the far end, fixed moment at A. And we have a formula for that when this is the loading. So moment BA is 3EI, which is, let's assume EI equals 1. So 3 times 2I is 2, 3 times E times 2I, so 2. So that's why we have 2 here over the length of the member 8. Theta near is theta B, the first letter here, minus delta over L, which is 0. Fixing the moment at B, this is the left, that's the right, so B is at the right of A. So it is positive. Formula PAB squared over L squared. So 30, A is 4, distance from B. Then B is also 4, distance from the other end, square over L square. So this is the general formula, even if there is a direct formula which is PL over 8. I will still use this because after all the result is the same, and this is general. Then minus 1/2 fixed moment at A, which is negative because it is in the left, same formula, but treated negative because A is in the left. So therefore MBA simplifying is 0.75 theta B plus 45. Call that equation 1. Then we proceed to setting up MBC. We have uniform load. MBC, so 2EI because there are expected moments at B and C at the ends. This is an interior span also. So MBC is 2EI is 1 over 6. 2 theta B plus theta C minus 3 times delta over L, 0. Then fixed moment at B, it is in the left, so negative WL square over 12. So negative 26 square over 12 only, because the far end is fixed. It has moment rather. So MBC is 2/3 theta B plus theta C over 3, then minus 60. Call that equation 2. MCB, you interchange coefficient, and because of symmetry of the loading, the fixed moment at C is positive CB, so you just make this 60. So CB is theta B over 3, interchange coefficient, plus 2/3 theta C, then plus 60. Or you may set up the equation, then verify that that's it if you're still inexperienced with slope deflection equation. So next is MCE. So 2 times 1 over 8, 2 theta C plus theta E, which is 0, minus 3 times delta over L, 0. Then fixed moment at C is negative WL square over 12, negative 28 square over 12. So MCE is 0.5 theta C minus 320 over 3. Call that equation 4. Then EC, so you double theta C, E, which is 0. So theta C will now just be 0.25 theta C. Then because of symmetry, the fixed moment at E, or EC in particular, is positive of 320 over 3. So that's the equation for moment EC. Then we have moment CD finally. Far end is pinned, so 3EI over L, the formula. There's no loading, so there's no fixed moment. So moment CD is 3 times 3 over, because this is 3I, over L, which is 8, theta C minus delta over L, 0, on the side sway. So simplifying, MCD is 9 over 8 of theta C. Equation 6. We now have equilibrium equation, MBA plus MBC equals 0. MBA is 0.75 theta B plus 45, while MBC is 2/3 theta B plus theta C over T minus 60 equals 0. So combining like terms, then setting up the first equation, 17 over 12 theta B plus theta C over 3 equals 15. Call that equation A. Then at C, equilibrium, MCB plus MCE plus MCD equals 0. MCB, theta B over 3 plus 2/3 of theta C plus 60 plus MCE, 0.5 theta C minus 320 over 3 plus MCD, 9 over 8 theta C equals 0. Combining like terms, setting up the second equation, we have theta B over 3 plus 5 over 24 theta C equals 140 over 3. Equation B. Solving these two equations simultaneously, then we get theta B equals 6.0022 over EI, while theta C is 19.4906 over EI. Remember, these are slopes, so there will be EI, and we just assume EI equals 1 in this slope deflection equations. So having found these thetas, we can now compute moments. So moment BA is 0.75 of 6.0022 plus 45. So moment BA is equal to 49.502 kilonewton meter. Moment BC therefore is negative of this value. So there's no need to compute. Moment BC is negative 49.502 kilonewton meter. Take note of joint B. If BA is positive, BC is, if BA is negative, then BC is positive. If BA is negative, then BC is negative. If BA is positive, then BC is negative, as shown. Then moment CB, theta B over 3, 6.0022 over 3 plus 2/3 of theta C plus 60. So moment CB is 74.994 kilonewton meter. So at C, there are T members attached. So we have to solve for the other moments. Moment CE is equal to 0.5 of theta C minus 320 over 3, and that is equal to negative 96.921 kilonewton meter. Moment CD, 9 over 8 of theta C. So it is equal to 21.927 kilonewton meter. So we're now ready to solve for reactions. So moment EC on the other hand is 0.25 of 19.4906. Moment EC, then plus 320 over 3. So 111.539 kilonewton meter. So let's have these moments on the next slide, and let's compute for the other reactions. So for the calculated moments, these were the results. So beginning with BC perhaps. So these are the applied moments in their correct directions because we have found the moments already, and for the reactions also, anticipations as shown, then at E. So these directions for moments are based on these results here. So beginning with AB, so summation moment B equals 0, AX times 8 plus this moment here MBA, which is 49.502, then equals 30 times 4. So AX is equal to 8.812 kilonewton, and the direction is correct leftward. Then shear at B just to the right, summation moment C considering BC. Shear at B just to the right times 6 plus this moment here CB 74.994 equals this moment here, which is 49.502 moment BC, then plus the moment of the load 20 times 6 times 3. So shear at B just to the right is equal to AY 55.751. So AY is 55.751 kilonewtons, and it is upward. Next, to solve for dy, we need shear at C just to the left and shear at C just to the right. So let's consider BC first. Summation moment B equals 0. Shear C left times 6 plus this moment BC, which is 49.502, equals this moment CB 74.994 plus moment of the load 20 times 6 times 3. So shear at C just to the left is equal to 64.249 kilonewtons. Shear at considering CE, summation moment about E is 0. Shear at C just to the right times 8 plus moment EC equals moment CE plus moment of the load 20 times 8 times 4. So that is shear at C just to the right times 8 plus moment EC, which is 111.539, equals moment CE 96.921 plus moment of the load 20 times 8 times 4. So shear at C just to the right is equal to 78.173 kilonewtons. If you draw free body diagram of this column, transmit these shears, then dy is the sum of 64.249 and 78.173. So therefore 64.249 plus 78.173 is 142.422 kilonewtons. So finally for EY, we have dx, summation moment C considering this column here, dx times 8 then equals this moment here, which is moment CD 21.927. So dx therefore is 2.741 kilonewtons rightward. Then for EY, summation moment C considering CE, this is for CX considering the entire system. So summation versus x equals 0, 30 plus dx 2.741 equals ax 8.812 plus ex. So ex is 23.929 kilonewtons, and that is leftward. Then considering CE, summation moment C 0, EY times 8 plus moment CE, which is 96.921, equals moment EC, which is 111.539, plus moment of the load 20 times 8 times 4. So EY is equal to 81.827 kilonewtons. So we're now ready to sketch the shear force diagram. So beginning here, our top fibers will be the left side this time because of this loading here. So we are given the idea that the left fibers would be the top cords or top fibers, And of course, for the upper beam, the top fiber is the top. So AX is 8.812. So this is the left, that's the right. So 8.812 to the left. Then constant up to here, minus 30. 8.812 minus 30 is negative 21.188, then constant. So it should close there. Then shear at B just to the right, which is equal to 55.751. Then minus 20 times 6. So we have a line here. So that's negative 64.249. Shear at C just to the left. Correct. Then the distance is 55.751 over 20, 2.7876, or you solve that by similar triangles. So this is 6 minus 2.7876, so 3.2124 meters. And shear at C just to the right is 78.173 minus 20 times 8, same line. So it should be EY in magnitude, and it is negative 81.827. It's correct here. This distance is 78.173 divided by 20. So by the way, for this part, this is the top fiber at the left. So if dx is rightward, then you go down. Dx, which is, because this is the left and that's the right. So dx is negative, so dx down, negative 2.741, then straight up. So the area is negative, then it should close there. So that's a shear force diagram. We will have this distance later in preparing the moment diagrams. So beginning with A0, then plus 8.812 times 4. So we have a straight line here. So 8.812 times 4 is 35.248. Then minus this area, 21.188 times 4. So you'll have 49.504 is the moment BA or BC. Then negative 49.504, 502 the real value. Then plus the area 1/2 of 2.7876 times 65.751, positive decreasing as shown, and you will have here 28.202. 28.202 minus this area 1/2 of 3.2124 times 64.249, negative increasing. So this is negative 74.995. It's close there. Then moment CE is negative 96.921 plus the area here 1/2 of, so we have to solve this distance, 78.173 divided by 20, 3.9086, or you solve that by similar triangles. Then this is 8 minus 3.9086, so that's 4.0914. So negative 96.921 plus 1/2 of 3.9086 times 78.173, positive decreasing. Then the value here would be 55.852. 55.852 minus this area 1/2 of 4.0914 times 81.827. Then you will have here value of negative 111.541, 541, which is close to that value, so that's fine. Then for this diagram, beginning with 0, the area is negative. So 0 minus 2.741. Remember, this is the top fiber at the left. Minus 2.741 times 8. So we'll have negative 21.928. That's the diagram. Remember, this is the top fiber. Then that's already the bending moment diagrams completed in kilonewton meter. For the elastic curve, so top fiber, remember, at the left. So we have a positive concave up somewhere here, then concave down, concave up, concave down, down, then concave up, concave down. For this portion, concave down, concave up, and concave down. For this column, because this is the top fiber, so negative moment means concave down. So it's like that. So we can now sketch the elastic curve as shown in the figure. So that's the way I approximated it when I mentioned the elastic curve. So that's it, and I hope that you were able to follow the explanation and solution especially.